continue from where we stopped in the last video, which please you can go and watch if you have not watched. Now we are also going straight forward to talk about some other transform that we have, right? So when you have another function g of t, right? Integral from 0 to t. Now f of tau, right? The tau, then this transform is going to be g of s, which is just f of s upon s. Now quickly we are going to go straight to some familiar transform also when you have f of t, where tau, you remember, if alpha is greater than 0, then this transform is just going to be 1 over alpha, then you have f of s upon alpha, right? This is a straightforward transform. Then we have done this one. We have at, right? F of t. Now this clearly is just 1 over alpha, then you have f of s upon alpha, right? Then some other common ones you will see is if you're giving t f of t to transform, after that transform you're going to get df upon ds, right? Similarly, if you're giving generally t of k, t raised to power k, f of t, then this should be generally minus 1 k dk f of s, then upon ds raised to power k. So we can use it to get the value here. From here you can see this particular one is just when k over here is equal to 1, right? When k is equal to 1 over here, right? This is k. If k is equal to 1, you only have going to get t, then f of t, right? So k is 1, so I left with minus 1 over here. The k is 1, you see, so f of s, right? So this is f of s upon the s raised to power 1, which is over here. So similarly, we are going to get if you have t, the function of t upon t, and you are asked to transform this, this is simply s. You're integrating from s, f of s, ds, right? So this is straightforward. Now we have some specific ones we're going to be talking about. Some specific, we have solved some, but let me give you some specific, so that if the function is 1, the transform is going to be 1 over s. We have done this in the previous video. If it is this, you're going to get 1. If it is this, so generally you're going to be getting s raised to power k. Now if you're transforming the function t, you're going to get 1 over st if they give you t to transform. So generally, if you're giving t raised to power k upon k factorial, what is factorial? K greater or equal to 0. So factorial, you can watch the previous video to know more about factorial. But if you're giving a number n factorial, so that n factorial is just simply you have n into n minus 1 into n minus 2 into continuously until you exhaust that particular n. You now have 3 times 2 times 1. For instance, if I have, give me 5 factorial, so 5 factorial is going to be 5 into n minus 1, 4 into n minus 2, which is 5 minus 2, 3. Then you have continuously you have 2. Then you have the last one will be 5 minus 5, which is 0. So you are going to have 0. You are going to stop at 5 minus 5 because you should not get 0, because 0 factorial is equal to 1. So this is the meaning of factorial for those that don't know about factorial. So if you have given this to general formula, you're going to be getting 1 upon s raised to power k plus 1. This is the general formula. So we have done this in the previous video, e raised to power at, which we got 1 over s minus a. Similarly, when we did for a minus at, when we did the integral, I think we got 1 upon s plus a. Good. So in the next video, I'm going to be giving you more and more example. Then we're going to be going into the trigonometrical transformation. So what that has to do with cosine, sine, tangent if possible. So and then